This lesson is going to take a look at some types of angles that are made by parallel lines and lines intersecting the parallel lines called transversals that you may have never heard of before. So it helps when taking notes in this lesson if you have different colors available to highlight or color in certain portions of your notes. So the first type of angles we're looking at in this lesson are vertical angles. Those are just two angles that are across from each other that are formed by intersecting lines or lines that cross. And then something important to note is vertical angles have the same measurements. So when we look at the diagram in a moment, I'm going to be color coding some of the stuff. The stuff that I'm color coding in each picture that is colored the same color will have the same measurement. So let's take a look at this. You have two intersecting lines, and vertical angles, again, are angles that are across from each other and have the same measure. So as you can see from the picture, it tells you that angles A and angle C are vertical angles. So if I were going to color code angles A and C, I would color them the same color because they would have the same measure. If angle A was 65 degrees, angle C would then have to be 65 degrees as well. It also tells you that angle B and D are across from each other or vertical as well. So I would color those two a different color because while they are vertical angles, they are equal to each other, not equal to the red ones. So let's say this tells you that angle A in this picture is 60 degrees. So then that would have to make angle C 60 degrees as well because the angles are vertical to each other, so that would make them the same measurement. Now, here's where the tricky part is, because we're not using a protractor, which is a tool that measures the degrees of angles. We have to then be able to figure out what angle D and angle B are together. So let's take a look at some things that we know and incorporate some of the stuff that we learned in the previous lesson on complementary and supplementary angles. So if we're looking at angle A starts down here, and I'm tracing it in green, and ends up here, right? Angle D starts off where angle A stops, right here, and then opens up and goes down here. So those two angles together, angle A and angle D, form this straight line that I'm highlighting here in red. And we know a straight line or a straight angle, those are supplementary angles, are 180 degrees. And just like what we did in the previous lesson, if I know the whole thing should be 180 degrees and I know I use 60, I should be able to subtract what I know from what I want and it will get me what is left over. So if I subtract here, 80 or 0 minus 0 is 0, 8 minus 6 is 2, and then 1 minus nothing is 1. So then I know that angle D up here has to be 120 degrees in order to make that straight line. And then we can also then use that value to find angle B because angle D and angle B are across from each other. They're vertical angles and they have to be equal. So then this would be 120 degrees as well. Some other new vocabulary words are transversal. When we're talking about parallel lines, which are the rest of these angle types focus on, we are looking at a transversal, which is a line that intersects the pair of parallel lines. And then we have three types of angles that we make using those. We have corresponding angles, which are two angles along a transversal in the same position. Alternate interior angles, which are two angles that lie on the inside, opposite sides of the transversal. And then alternate exterior, two angles that lie on the outside opposite sides of the transversal. That all means nothing unless you see it, right? So let's take a look first at the corresponding angles. Corresponding angles are defined as two angles along a transversal that are in the same position. So what you see in the diagram here is a transversal, and then you have two lines that are parallel that it intersects, and it makes 8 angles, which they're numbered. Okay, so corresponding angles, the way I describe it is think about the angles as being different class periods of mind. Let's say this is first period, that parallel line, and this, let's say, is second period. So if I say that you, right now, if I'm making my seating chart, if I say that you are seated right here where angle 1 is, so I'm going to color your seat red on my seating chart. Now, if we're looking at second period, you're not in second period because you're in my first period. But if I'm looking at my second period class, the desk that you sit in is still there, right? So if I were to mark the same desk with the same color, what number would I mark? I would mark number 5. Because if I were to put the first period line on top of your second period line, 1 and 5 would be on top of each other. So they're colored or marked the same color. And again, I'm coloring these the same color because they have the same measurement. So I could say the same thing about angle 2. If I color angle 2 a different color because that's your neighbor's desk would still be in the same spot in second period, but your neighbor would now be corresponding to number 6. Then I could say number 3. If I color number 3 green, if I have number 3 correspond to something in second period, the same location, it would be number 7. And then if I had number 4 correspond to something, it would correspond or be in the same place as 8. So basically, corresponding angles are 2 angles that are in the same position but on different spots along the transversal. So along the different spots of the parallel line. So I should be able to pick up that first parallel line or first period, and I should be able to put it directly on top of my other parallel line, my second period, and it would be in the same place, in the same measurements of the angles. Like I could pick up my seating chart for first period, and I could put it directly on top of my seating chart for second period, and it should be identically the same, with the exception of the names of the students that are listed in each class period. This furniture would still be in the same locations on the paper. This time, we're looking at alternate interior angles. Alternate interior angles are formed on the inside of the parallel lines. So if I highlight the parallel lines here in yellow, right, I'm looking at the angles that are in between those parallel lines because they're alternate interior. So the inside angles, and in this picture, are number 2, number 3, number 5, and number 8. So alternate interior, the definition was that they were on the inside, but they were on opposite sides of the transversal. And again, what I'm coloring in the same color has the same measurement. So let's say I'm focusing on angle number 2. If I color angle number 2 red, I want to find another angle out of the inside ones, remember 3, 5, or 8, that looks the same size and shape as the number 1, or the number 2, I'm sorry. So if I colored number 2 red, out of my choices 3, 5, and 8, the only other one that's big like that, obtuse, would be number 8. So I would color it. They are alternate interior because they're on the inside of the parallel lines, but they're on opposite sides of the transversal. One's on the right, and the other one is on the left. So then that leaves my other pair of alternate interior angles to be acute, which is my angle 3 and my angle 5. Again, one of them is on the left side of the transversal, and one of them is on the right side of the transversal. And again, they're colored the same color because they have the same measurements. Alternate exterior are exactly the same thing as alternate interior angles, except if I highlight my parallel lines again here in yellow, the alternate exterior angles are the ones that are on the outsides of the parallel line. So I'm looking at number 1, number 4, number 6, and number 7 in this particular diagram. So if I match them up again to have one on each side of my transversal, if I colored number 1 red, I want another small angle like that. And so the only other one out of 4, 6, or 7 that matches it should be 7. So I'm coloring 7 the same color, again, because they have the same measurement. Then that leaves me with my obtuse angle or my big angle, which would be angle 4, and it would have to pair up with angle 6. And again, they're colored the same measurement because they are the same color because they have the same measurement. So what is all this useful for? What all this is useful for is you're going to eventually see a problem like this, where you have a diagram and you only know one or two things about the angles in that diagram, and you have to then be able to figure out what is the value of all of the other angles. And again, you're not using a protractor. You have to use all those different types of angles and what you know about their measurements in order to figure out what the rest of them are equal to. So let's take a look at it. We know two things. We know two of them in the bottom corners. So let's focus on the one on the left first. So we know that that particular angle is 45 degrees. That should tell us something about angle 8. Angle 8 and the 45-degree angle are vertical to each other. So remember, vertical angles are angles that are across from each other. So then that means they have the same measurement. So I know then that angle 8 is 45 degrees. Okay, so then I can find angle 7 because I know that angle 7 and angle 8 make that straight line that is directly underneath them. And if they make a straight line is 180 degrees, which means angle 7 and 8 are supplementary to each other, so I can subtract the 45 degrees that we know from the 180 degrees that we want. So if I subtract the 5, I can't take it from nothing, so that becomes a 10, and the 8 becomes a 7 because we borrowed. So 10 minus 5 is 5, 7 minus 4 is 3, and 1 minus nothing is 3, or 1, sorry. So that means I have 135 degrees as my angle number 7, which should then make my angle 9 135 degrees as well, because angle 7 and angle 9 in this picture are across from each other, which makes them vertical, which also makes them have the same measurement. Now, I can do the exact same thing on the other side with what we know. So I know that the 40-degree angle is vertical or is across from angle 10. So I know that angle 10 has to have the same measurement as the 40-degree one, so it has to be 40 degrees. I know angle 10 and 11 make the straight line underneath them. So again, that's 180 degrees, so I have 180 minus the 40 that we are using. I subtract, I get 0, 8 minus 4 is 4, and then I have the 1. So I know 11 is 140 degrees, which then makes angle 13 140 degrees as well, because angle 11 and angle 13 are vertical to each other. Okay, so now we have the bottom half of our picture filled in. I want to then look at the top. So this is now where it kind of becomes hard to envision some of this stuff. So you've got to pretend that the other transversal doesn't even exist. So you're still looking at the parallel lines and one transversal, but you have to determine what you're looking at without that other transversal being there. So let's pretend that that line isn't there. So if I'm still looking over here at the blue side with the 45-degree angles, I want to go up top. If I picked up those parallel lines and I match them up with something, what would correspond with each other? Well, if I picked up that parallel line on the bottom and I put it directly on top, I would have corresponding angles. Angle 45-degree angle would correspond directly with the angle 5 up here, because it is on the bottom left of the transversal. If we picked it up, angle 5 is on the bottom left of the transversal. So this would be 45 degrees as well. If angle 5 is 45 degrees, angle 2, which is across from it, has to be 45 degrees as well, because they're vertical from each other. Okay, so let's do the same thing with the bottom. If we're looking at the bottom, if I were to pick up the other side, the green side, and put it up on top where the other parallel line is, if I'm looking at angle 10 is going to correspond to angle 3. It's on the bottom right of the transversal. So if angle 10 is 40 degrees, angle 3 has to be 40 degrees as well. Angle 6 is then also going to be 40 degrees because it's vertical or it's across from angle 3. So angle 6 is then 40 degrees as well. So now we have to think about some of the angle relationships that we know in order to get angles 1 and 4. And angle 1 and angle 4 would have the same measurement, because they are vertical or across from each other. So let's take a look, and I'm going to highlight this here in red for a moment. But if we're looking at angle 2 starts here at this parallel line, and then it goes up here. Angle 1 starts off here where angle 2 leaves off and goes here. And then the angle 6 that we just labeled 40 degrees starts off where angle 1 stops, and then it goes here. So together, they make this straight line going horizontally across that I'm making thicker. Okay? So I know that that straight line has to be 180 degrees. I know also that we've already used angle 6, which is 40 degrees, and angle 2, which is 45 degrees of that 180 degrees. So I'm going to take the two angles that we know, the 40 and the 45, and I'm going to add them together. So 5 plus 0 is 5, and then 4 plus 4 is 8. So I know the parts that we've used so far are 85 degrees. Because they make that straight line, all three of them, they're supplementary, right? Which means that they make 180 degrees together. So I can take that 180 degrees that all three of them would be together, subtract the 85 that's already been used, and that should give us what we have left for angle 1. So if I subtract, I can't take 5 from nothing, so that becomes a 10. The 8 becomes a 7. So 10 minus 5 is 5. 7 minus 8 I can't do, so I have to borrow. That 7 becomes a 17, and then the 1 becomes nothing. So 17 minus 8 gives me 9. So then that angle 1 would be 95 degrees. And then, like I mentioned before, angle 1 and angle 4 are across from each other. They're vertical, so then that would make angle 4 95 degrees as well. So then we have filled in every part of that particular diagram. Now, the thing I like about this, I know it's kind of confusing and it kind of feels like if you look at it upside down or backwards or something, it might make more sense. But what I like about this is the way that I just did that is not the only way you could have done that. You could have used pretty much almost any of those angle relationships that we've talked about earlier in this video, and maybe even some of the stuff from previous videos, and you could have put it together to make the values of the other angles. So is this the only way that you could do that problem? No. There are multiple other things, like you could have used alternate interior and alternate exterior angles as well. So keep that in mind for what you're doing. This is not necessarily the only or the end-all be-all way for you to complete a diagram like this.